Hello everyone! In this lesson, we'll study the UOP signals of FANUC industrial robot, including the functions and the configuration methods of UI and UO signals. First, let's learn about the functions of UI and UO signals. UI signals such as MSTP, HOLD, and SFSPD are used to control the robot's start, pause, and shift speed. UO signals such as CMD, ENBL, as well as RDY and PROGRUN reflect the robot's operating states, such as common enable, system ready, and program execution. Understanding this signal helps other peripheral devices better control and monitor FANUC robots. First, let's look at the UI signals. There are 18 UI signals commonly used to control program start, pause. Next, let's learn about several commonly used UI signals. UI1 is MSTP, immediate stop signal. When this signal is off, the tech pendant displays the servo 037 alarm message. The robot will immediately stop and apply the brake, and the servo system power will be turned off. During allocation, as shown in the right diagram, the allocation starting at point 1 for rack 35 and slot 1 is a normally closed point. Next, please answer this question. What happens to the robot when the UI1 IMFTP emergency stop signal is off? A. The robot accelerates. B. The robot decelerates and continues executing the program. C. The robot stops urgently and applies the brake with the servo system power turned off. D. The robot enters standby mode. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. UI2 is hold signal. When this signal is off, the robot decelerates to a stop. The program pauses, and the pause status on the tech pendant displays in red, as shown below. Next, please answer this question. Which of the following UI signals should be on under normal conditions, and when off, causes the robot to decelerate and stop and pause program execution? A. IMSTP. B. Hold. C. SFPD. D. Single stop. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. UI3 is SFSPD, safe speed signal. When this signal is off, the robot can move in automatic mode. In T1 or T2 mode, the robot can move manually, but the speed is limited below the safe speed. The specific safe speed value can be viewed in the system variables, as shown below. UI4 is circle stop signal. This signal can abort the currently executing program. The specific application method is as follows. In system configuration, when item 9 false program abort with CSTOPI signal is disabled and UI4 is on, the robot will complete the current program before aborting. For the functions of other UI signals, please refer to relevant materials for further study. Next, let's look at the UI signals. UI1 is CMD ENBL, Command Enable Signal Output. When this signal is on, it indicates that the robot meets the operating conditions and can start the program. U2 is SOS RDY, System Ready Output. When the servo system power is turned on, this signal is on. U3 is PROG-RUN, Program Running Status Output. When a program is running, this signal is on. We have only provided these examples for UO signals. For the functions of other UO signals, please also refer to relevant materials for further study. Next, let's learn the configuration methods for UI and UO signals. To truly use these UI-UO signals, they must be allocated. FANUC industrial robots provide an automatic allocation function for UOP signals to simplify this process. As shown in the diagram, this is the automatic allocation for UOP signals. The main difference between simple and complex lies in the allocated UOP sequence numbers. Next, let's demonstrate the allocation method.
Alright, let's demonstrate the allocation method. Let's take a look at the automatic allocation method of PO. First, let's look at the state of UOP. Click Type and then find UOP. Now we found that the status of UO is all asterisk and has not been allocated, and the state of UI is also asterisk and has not been allocated. Then let's look at the allocation. The UO1 20 rack number and slot number are both 0. Click Menu, then click Next Page. Click System, click Configuration, then click Item. Enter 44 and click Enter. We can see that 44 UOP automatic allocation shows disabled. we click Select, and here is the automatic allocation method. We click on Abbreviation, and now it will let you restart. So we restart it. Alright, after restarting, let's look at the UOP again. We found that the state of UO has changed, and the state of UI has also changed, indicating that the automatic allocation was successful. Then we click on another column, and we found that UI 1, 2, 3, and 4 are all allocated to racks 35 and 32 respectively. Next, let's look at other allocation methods. Found the interface before. Click Select. There is another allocation method, such as 7 abbreviation. So we won't demonstrate it here.
Although automatic allocation is convenient, we sometimes need to configure according to actual condition, which requires using the manual allocation method.
This is the unallocated state. If we want to make manual allocation, we must first turn off the automatic allocation function of the system. We found the corresponding variable. Alright, let's enter 266 here, and then we can see that 274, 273 are both false, which means the auto allocation has been turned off. Then we enter the manual allocation, and what we want to distinguish is UI1, UI2, UI3, UI4, and UI8. First, let's look at UI1 to UI3. The rack number is 35 and the slot number is 1. Then we don't allocate UI4 to UI7 but UI8. UI8 is the same as UI1 to UI3. Its rack number is 35 and the slot number is 1. For start point, since UI1 to UI3 have already been allocated, the start point here should start from 4. Alright, we can see that the status here has changed to panned, and the lower left corner prompts us to restart. Let's restart. Alright, after restarting, we enter the UI1 interface. We can see that the states of UI1, UI2, UI3, and UI8 have all changed to on. The FANUC robot can only move when these 4 points are all on.
Next, please answer this question. Which of the following description about UOP signal allocation for FANUC industrial robots is incorrect? A. FANUC provides an automatic UOP signal allocation function. B. Manual allocation of UOP signals typically doesn't require considering actual condition and specific needs. C. Automatic allocation and manual allocation are two common UOP signal allocation methods. D. Using automatic allocation can simplify the UOP signal allocation process. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, everybody. In this lesson, we learned about the functions and the allocation method of UI and UO signals for FANUC robots. These signals are crucial for effective communication and control between the robot and the peripheral devices. After this class, please find more information about other UI and UO signals and try practicing signal allocation in a simulated environment. That's all for this lesson. See you next time.